Hi guys, today I'm going to be showing you a little bit on the physics of my hopper. So in here we have a rubber band. You twist this to get torque in there and get this backside to move back and forth. So I'll be comparing the energies from the rubber band in here and the kinetic energy from the fin. We start off with the energy of the rubber band. So torque is equal to force times distance times sine of theta. Now the distance would be from the axis of rotation to the force. That's 7 centimeters. Now, to calculate the force, I need a mass. So I use different coins. So different masses gives me different torques. So I'll show you guys how I use this. So you count the number of rotations to the point where this rod is parallel to the horizontal. So at that point, you actually write down the values. And then with this, we can create a graph. Torque in the y-axis and theta in the x-axis. Since torque is a type of force, we can integrate it to find the amount of work that was done by the rubber band. So after the calculations, I found that to be 0.206. Looking at the energy of the fin, we have kinetic energy is equal to 1/2 the moment of inertia times the angular velocity. So the moment of inertia is equal to the mass times the distance from the point of rotation to the center of gravity squared. So we know the mass to be 0.75 grams. The distance from the center of gravity to the point of rotation is 3 centimeters. And the angular velocity is 12.47 radians per second. So to find that, I counted the number of rotations and give a number of time. Since we know that the angular velocities at each side are 0, that would be the maximum angular velocity. So plugging these numbers in, that gives us 5.25 times 10 to the negative 5 joules. Looking at the comparison of energies, the work of the rubber band is more than 50 times bigger than the energy of the fin. So that's the case because in order to actually get movement back here, you need to rotate this like 100 times. And when you do get movement, short bursts of energy. So most of the energy is still stored in the rubber band. So not all of that energy is converted to kinetic energy. In conclusion, the work by the rubber band is not equal to the kinetic energy of the fin.